Hi, in this video what we're going to do is we're going to evaluate piecewise functions. It's the first part of 3 lessons in this section. So let's take a look and see what is a piecewise function. And you have this set of notes in front of you, and this would be a piecewise function. It's in different parts. I like to call this the Frankenstein graph because you're basically taking different parts and piecing them together. Hence the piecewise function, and kind of did that with Frankenstein. We pieced them together. So anyway, evaluating functions are fairly easy, this particular part of this, because we've done this before. And basically what we're going to do is we're going to see what is the value of y when x is equal to -5. So we're going to come over here and we're going to look up -5, and then we're going to read the number on the y-axis. And so that's basically all we're going to do throughout this entire 6 questions. So the first one is going to be equal to 5. The next one, what's the value of y when x is equal to -3? So we're going to come over here to -3, and we're going to notice that we have +3 and we have something going on at -3. However, we have to disqualify the -3 because there's a hole there. It's not defined. So our answer will be +3. And the next one, I kind of jumped ahead of myself. The value of y when x is equal to 0 is -3. And try to do the last 3 on your own and see what you come up with. I'll take a minute and pause, or you can pause the video. That'd be better. All right, so the answers to the last 3, the value of y when x is equal to 3 is 3, the value of y when x is equal to 6 is 6, and the value of y when x is equal to 1 is -3. So that's fairly simple. Now, the next set of questions, we don't have a picture. We just have 2 equations. And let me back that up. And we have restrictions on these equations. So we're only going to use this equation when the value of x is greater than or equal to 0. And we will use this equation when the value of x is less than 0. And remember, these are your values of x right inside these parentheses. So the value of y when x is equal to -9, the equation that we're going to plug that into is this one right here, because the qualifier, -9, fits into this restricted area. So when we take out this x and plug in the -9, I'm covering up that negative right now, we're going to get a -9, but then we're going to negate that, so it'll be +9. The square root of +9 is 3, and then we're going to negate that answer and get -3. Okay, 16, we're going to plug into the first equation because 16 falls in under this set of instructions, numbers bigger than or equal to 0. So plug in the 16, the square root of 16 is 4. We're going to multiply it by 2, and the answer is going to be 8. The next one is obviously 0. Let's see how we got that. This is where 0 would fall. And so when we plug 0 in here, the square root of 0 is 0. Anything times 0 is 0. Okay, the next one, 2. Pick which equation you're going to plug that into, the first one or the second one. If you chose the first one, you were right, because 2 is bigger than or equal to 0. So when I plug a 2 in here, the square root of 2 is not a perfect square, so I have to leave it the square root, 2 times the square root of 2. -25. Pick which equation you're going to plug that into, the first one or the second one. If you chose or thought the second one, you were right. When you plug in a -25 in for x, it's going to be -25, but then you're going to convert it to a +25. The square root of +25 is 5, and then you're going to negate that answer. So the answer will be -5. Now the next answer question, it was missing a number here, so we put -2 in there. You can do that as well. -2 falls under this set of restrictions. So when I plug a -2 in for x, I get a +2 underneath the radical. Square root of 2 is not a perfect square, so just leave it there. And your final answer will be the negative of square root of 2. And it's negative again because this is negative. All right, so that concludes this lesson. That's how you evaluate piecewise functions given either a graph or the equation.